Okay, recording has started. Finally works. So welcome to those that are not listening to us right now, and they will watch this later on. We just catch up before starting recording. Here I have two accounts. One of them is Ali Riza Kitasi that is showing in the top. Another one is demo. And here I have a video. The reason for that was that simply my webcam wasn't working, so I used iPad. Because I wanted to show you how the PLCs look like and things like that as part of this course. Anyway, to start with, I'm pretty sure that you all have seen this site. It's actually a little bit annoying. I can hear myself, so if we move this to the top, so I can hear myself that way. That works better for me. Okay. And we have this distance learning assessment. So hopefully it was clear for you guys. Last week we had some teaching around relays. Okay, so for this relays, especially if you are an electrician or you have industry experience, it shouldn't be something special. It is just normal relays, normal contactor. So we use them very often, especially if you use a motor or sort of you have a high current device, you definitely need to make use of a contactor, and you can get the signal straight away from the PLC. I had some tasks to do. Also, another thing that we looked at last week was about this electrical symbols, because it is very important to read engineering drawings, and it is very important for you guys to actually understand these symbols, what they are. The symbols are very basic symbols. I'm pretty sure that you have seen most of them. It's basically a review. Some of them are more important than the others for PLC programming. One, things like, for example, switch or connections or voltage source are very important use as well. So my expectation is that you need to have a good understanding of that. Anyway, I don't expect, if you haven't seen that before, I don't expect you to remember that all. But anyway, later on, if you got some drawings and some of the symbols didn't make sense to you, all you need to do is to just come back to this window and see what's the common and things like that. Okay. What we wanted to do today is actually starting with PLC. And just before I forget, you have some assignments and some works to do. Maybe you realize that I haven't replied to the emails about the assignments. We usually don't do that because they will be assessed, basically. Your activity will be assessed. So it is not something for normal. I mean, the discussion is a little bit different. You're not getting an immediate reply, whereas it is more going to be assessed, but we don't mind use a forum. We don't mind if we actually look at work of each other and get idea that how things work, but definitely all of you need to do that, otherwise obviously you lose a mark. And the detail of the assessments and how it works is right here, so you can see that we have 10% dedicated, 10% of the coursework dedicated specifically for completing these assessments. So make sure you just do them. It is an easy 10%, so hopefully you should be able to get everybody to have this 10%. Okay, before I start the topics, do you guys have any question for me or anything you wanted to discuss, either about the relays or the general information?
Yeah, I'd like to say, can people mute their sound so that we don't hear the background noises?
Pardon?
You're getting echo because of people muted their sound. It's Alt-A on the keyboard.
Yeah, that's the problem. If you guys actually could make use of something like that, it would be a lot better.
And you won't get the echo then either.
Yeah, that's right. But anyhow, this is it. So could you please just tell me any other sort of things, any course-related question? Or anything you wanted me to explain before going to new things? No? Oh, okay. Excellent. So hopefully we shouldn't have any problem about that. And I can straight away jump to sort of PLC, how the PLCs look like and things like that. I use this computer, this tablet actually, demo, to show you how it works and what is a PLC. It's a little bit small. Let me actually see if I can make demo bigger. It's getting red. Oh, that's my hand. Sorry. Can you see this? The PLC?
Yeah, I can see it.
Okay, cool. The top one is a PLC. As I told you guys, it's actually just a computer, like any other, oops, like any other computer, but with one difference. It has industrial inputs and outputs. It has industrial I/O, and on top of that, it is a lot more robust than normal computers. If you look at computers like this computers in front of me, you can see that it's actually not that robust. Whereas this PLC is a lot more robust, and you can basically install it in a site, and you can just forget about that. As long as the situation is not very harsh, it should be all right. You have wiring, you don't get something like, for example, a screen here. You don't have a keyboard, so the I/O here definitely are very different than the I/O that we used to have for normal computers. So for this PLC, if you look at this, the first block, this block, is actually the power supply. And you need power supply everywhere. Without power supply, you are not able to supply power to your device. So power supply. And then the next one here. Oh, okay. Yeah. The next one here is the CPU, Central Processing Unit. The central processing unit is the brain of your computer or brain of your PLC and manages everything. It is doing all the calculation. And also we have some other slots after that. And you can see that there is room for more slots as well. This PLC is a modern industrial PLC and can be expanded. There are also some other PLCs that they have fixed inputs and outputs. So inputs here, for example, this card is actually, a digital, let me actually have a look at that. Yeah, this is an analog input. It is receiving analog inputs. For example, if you have an analog signal you measure in a speed or you measure in temperature or something like that. As a signal can be wired here. The next one is a digital input. So like a switch, push button, or things like that, or a sensor limit switch can come here. And then the next one is a digital output. For example, you wanted to turn a light on or off, you wanted to turn a motor on or off, you do that right here, right here. Rest of the circuit is just another power supply, as you can see. This power supply is because the main power supply was not good enough to provide power for inputs and output. So we have an auxiliary power supply and we have terminals. Does that make sense, guys?
Yep, that's all good.
Yeah, I think so.
The PLC, this PLC is M340. This is a Modicon PLC. But the PLC that we're going to start with that is actually not that advanced. The PLC that we're going to start with that for this course called So Machine. So let me just show you how it is look like. We used to make use of another PLC called Twido. We used to use Twido, but then recently we realized that Twido is not compatible with Windows 10. And because majority of the students actually upgraded their computer to Windows 10, we needed to purchase a different PLC. And you can see that's the PLC. This PLC is So Machine. It's actually more advanced than Twido. So at the end of the day, it's not a bad idea to go and work with a more modern equipment comparing to the older equipment that was Twido. So you can see that, like for example, this PLC is compact and it doesn't have that sort of flexibility of moving I/O and wiring it yourself. So it just has limited number of inputs and outputs. And that's good enough for PLC program 1 or here as well. You can see that limited number of inputs and output, and also the processor, power supply, all packed in just one sort of package, all is in one package. So that's the PLC that we're going to use. Make sense, guys? The PLC.
Yeah, I might come and watch the video again later on, and just to make sure I haven't missed anything.
Yeah, absolutely. So, I mean, it's just an introduction, really. I mean, there is nothing special. I just wanted to show you that how they look like more than anything else. Okay. Now, how to do the programming? Programming, obviously, I guess most of you the studies are familiar with programming, like for example, using Visual Basic or using Visual C or using some other languages. But the programming language that we use here is a little bit different. We start with a programming language called Ladder. So ladder PLC. If you just write ladder, you just see a ladder. But if you say ladder and PLC, you can see some wiring or some diagrams like that. Why this language is getting that popular? It's actually not, not on the top of the PLC languages these days, and these days because of change of technology, a lot of people prefer to use some other languages. But the reason that this language, electricians especially use this language and they like it, is because it's very similar to normal electrical sort of normal electrical circuits. So for example, if you look at this for a motor, if you have basic information of the motor circuit, you can see that the motor has a lashing contact, has a start, so you push the start, and it goes to the other one. So what you're doing, you basically replicate what we used to do to realize, but here we do it in PLC. It was making more sense to electricians, electrical engineers to do it. Or look at this as well. For example, now, if you want to activate this signal, whatever it is, then you require this switch to be closed and that switch to be closed. Or, as an alternative, the other close, that switch, CR4, if it is closed, it basically can bypass this two altogether. So that's ladder programming, and it's exactly using the symbols, the normal symbols that we used to use for basically basic electrical engineering. And just before PLC and smart relays, or even these days, we have some timers. So for example, if you wanted to start that, exactly if you wanted to use a relay to start and change to delta or something like that, then what you do, you use a timer and activate the timer by contact, and after that, take a contact of that timer, which is a position showing how the timer works. For example, here, parallel with the motor, so you're saying either if motor 2 is engaged or timer is engaged in order to, for example, switch. So what I am saying here, this language is specifically follows electrical rules, because if you want motor 1 to get engaged from the electrical principle and understanding how electrical circuits work, then you can see that you need to have a phase and you need to have a neutral connected. If phase and neutral connected, the motor turns on. Okay. Now what we have on a way, we have a start push button. Also, we have the motor, which is parallels with the start. So either of motor itself, or either if the motor itself is running, or the start has been pushed, the motor is going. Is it making sense? Does it ring the bell? Are you there, guys?
Yeah, makes sense.
Yeah.
I guess it's pretty much similar to what you guys were doing before. How many of you guys actually have experience working with electrical circuits? Yes, good.
Yep.
Yeah, you got. Do we have anybody fresh, completely with no information about electrical circuits? This actually makes things easier, I reckon, because you all have experience with electrical circuits and you know how it works. So hopefully you will find the course very easy. Okay, now let us start with saw machine. First of all, where to get it? If you use the model, where's that? Okay, that's the courses, that's the one. Okay, under resources tab, there are some instructions for you guys to download Sew Machine. Or simply you can just search Sew Machine and you should be able to get it. So this software that we use here is Sew Machine, and there is a guide in installing Sew Machine basic PLC software. You should be able to download this file and install it pretty much on any Windows computer. This shouldn't make a problem for you. Now, let's have a look and see how it is look like. Okay, I start Sew Machine. Okay, it looks like that you're not seeing it. So I should stop the sharing and share. And just share my desktop. Share the screen. So now you should be able to see my screen and everything here. Okay, I started Sew Machine. If you install Sew Machine, you're going to have a shortcut like that, and you can start Sew Machine. Okay. Then once you started that, then I would like you guys to start a project, create a new project. Okay. And if you create a new project, then you have the controller. We have different types of controller. The software, the program that you're writing should be completely compatible with the hardware that you're writing it for that. So as you can see, we have different hardware here. So you need to make sure that that hardware is the right one. And if you wanted to change it, all you need to do is to just grab this and move it. And that way you can replace your hardware. Once you have done that, for this type of, there are some other settings as well. For this type of PLC, you don't need to really describe the hardware anymore because the hardware, it is all compact. All your inputs and outputs all described. Okay, but on the top row for this example, you have some terminals, and the terminal is showing here. And the bottom row also there are some terminals as well. All you need to do at this stage is to describe this terminal and say what they are. Okay. Let me make a simple program. So say for example, I have two switches, and if both of the switches are on, then a light turns on. Now I have another light. Either of the switches can turn that light on. Okay, so let me actually write it here so you can have the definition here for this example. There are two switches, SW1 and SW2. Lamp 1 turns on only if both switches are engaged. Lamp 2 turns on only on if either these two switches are engaged. Does it make sense? The task makes sense to you? What you need to do? What you wanted to do? So we have two switches and two lamps. Lamp 1 and lamp 2. Is it clear? Because usually, okay, I got something here in chat. Excellent. Yes. Sorry, my internet keeps cutting out. Okay. Thanks for your comment here. It's very helpful to actually know what is it, because always actually half of the answer is about understanding the question. So what all we wanted to do is just turn on and off two lamps using a couple of switches. Okay. So now we wanted to do that using this PLC. And looking at this PLC, you can see that we have inputs and outputs, digital inputs and digital outputs, and analog inputs. Switches are inputs, and because they only can be either high or low, they are actually digital. Digital what? Digital inputs. So what we can do here, we can give it a name. With a signal, you can see that we should actually wire them to the right place. So let's make use of the terminal 0 for switch 1, SW1, and let's make use of terminal 1 for SW2. So we assign these two terminals for the different tasks. The first one to receive information about the status of switch 1, and the second one to receive information about switch 2. Now we have digital outputs. Do we need to apply these changes? Yes. Now digital outputs. And we only have two digital outputs. Lamp 1. So let's wire that to terminal 0 right here. And the other one, lamp 2, let's wire that to terminal 1. And apply. Okay. Once we have done that, we don't have any analog inputs, we don't have any high speed or any other things, so we don't need to worry about that. We can start programming. Okay, we got one chat. Let's see what is that. There is a lot of background noise.
Sorry for that. Someone else
got their mic on.
Can I get
you guys to turn your mic off, please?
If you could do that.
I mean, that could be me, myself. Let me see.
No,
my mic is off actually.
On the tablet. Okay. Hopefully this, I think it is still useful. Yes. We have lots of background noise, but hopefully still you should be able to understand what I am doing. Okay, we have this, and we have done inputs and output. The next stage is programming. And look at this tab, programming. We can just click here, and we can write our program. And that's the environment that we have. Okay, now we want to make use of a program called ladder. Okay. And do all these tasks. Okay. That program, as I told you, is exactly have the logic of electrical engineering. So, okay, if you have two switches, and both of the switches need to be on to turn a light on, what are you doing? Are you going to connect it in series or in parallel? Reply using the chat, please. Yes, we got there.
There instead
Series.
series.
Correct.
Series is
right.
right.
So we need to just we go
to
another
another
chat.
chat.
Series for
and
setup. Exactly. Once
Once
you have the word and,
so
both
both
of them
them
need
need
to
to
be
be
on.
on.
So
So
in
in
this
this
case,
case,
it
it
is
is
quite
quite
reasonable
reasonable
to
to
make
make
use
use
of
of
series
series
contact.
contact.
To
So
make
make
use
use
of
of
this
this
contact,
contact,
you
you
can
can
see
see
that
that
on
on
the
the
top.
top.
It
It
is
is
series,
series,
one
one
here
here
for
for
one
one
switch,
switch,
another
another
here
here
for
for
another
another
switch.
switch.
Now,
Now,
for
for
lights,
lights,
they are
they
our
are our
output.
output.
We
We
use
use
something
something
called
called
coil
coil
on the
on the
top.
top.
If you
If you
look at
look at
that,
that,
it is
it
a
is a
coil.
coil.
Okay,
Okay,
so we
so you
just
just
say
say
this
this
one
one
and
and
that
that
one
one
goes
goes
to
to
the
the
coil.
coil.
Ali,
Ali,
can
can
you
you
move
move
your
your
iPad?
iPad?
I'm
I'm
pretty
pretty
sure
sure
it
it
is
is
not.
not.
Oh, okay. So it was me all this time. Yeah, apparently it was me all this time. Sorry for that. That's good that Darren realized that it was me. Okay, so we have symbol, and now there's two things. So we say that one switch, another switch, and after that goes to the coil. So we need to now give them a name. I mean, what is that? What we after? So the first one is switch 1, right? SW1. The second one is also SW2. And here it is goes to our lump 1. Now we wanted to look at the situation for lump 2. Lump 2 is again is an output. So first of all, let me to add lump 2, or maybe I can add lump 2 later on. Anyway, for this line I want lump 2, but now I want either of these two guys to be able to start and turn on lump 2. Can you guys tell me that how I should do that, series or parallel? For this situation, you got two chats. Yes, parallel. Yes, correct, it is parallel. So all we need to do is to just get this contact and another contact. We need to get them in parallel. How to do that? So get them in parallel. We can use this branch on the top. With branch, we can branch them. Okay, let me actually finish with that, and it goes to, oops, Control Z to cancel that. Here, so I basically got this here, and for, let's see, one chat. Use the pencil looking tool. Excellent. Yes, you know better. Yes, so we use the pencil and we could actually get them connected together. Absolutely. So now the symbol, again, SW1 on the top, SW2 for the bottom, and here for lump 2. This is it. This is our program for this part. Once we have done that, what else you want to do? You wanted to go to the next tab. and this is the program that we have. We wanted to basically process that. First of all, we should compile our program, make sure there is no problem with the program compiled, and after compiled, you can see that basically I didn't get error, but here it is saying that error is detected. So we should see that actually what's the error. Oh, okay. The error is in the top. They just basically need a number. Oh, okay. Actually, I clicked on that and I can see the message. The wrong should be splitted as it contains more than one equation. So you can see that actually if you got an error, it is telling us the OR in column 10 might be invalid because should start from the top. Okay, not a problem. So we can listen. This is from the OR. So you can see that one comment is gone, and it is saying that I actually need to split that to 2 because I have 2 actions. So I can't keep these 2 actions in the same place. So what should I do? I should simply go to my programming and I should make a new. You can see that add a new rung. I should make a new rung and I should move one of these things, one of these lines. Basically, I can copy and paste that all together. Cut that basically to another section because it wanted to make sure that for each action you have a section. So this is one action on the top and one action on the bottom. Now again I go and press compile to see if I get any error or not. This time I don't have an error. Actually, guys, a big and important part of programming is actually debugging, and PLCs also work in different ways. So it is important that you need to see if you got an error and you need to follow the instruction and you need to make sure what you are doing is what the program wants. Okay, after we have done that, we have display. We can go to the display. Okay, configure in this one. So that's mainly some advanced work. At the moment, you don't need to worry about that. And finally, we had commissioning. So commissioning is where you have done the work and you just wanted to download it to the PLC. Now, there are some information that you can add. For if you, especially if, say, for example, you wanted to sell this device. Also, if you wanted to make use of TCP/IP to sort of connect, if you wanted to make use of TCP/IP, like for example, Jack 40, 45 to communicate, you need to actually say that what is the IP address of the device that you have if you wanted to communicate with Ethernet. If you wanted to communicate with serial, then you don't need to really do much stuff, and you just need to say that it is serial, but you just need to say that which port is that anyway. This computer that I have here doesn't have any serial port, so it is not popping up here. But one option that is available, and now I just wanted you guys to work with simulation until you get to WinTech. is actually simulation. So with simulation, you can see how it works, and you can basically debug your program and see how it works, and try your program. So now I launched the simulators, so the simulation is working. It is in a run mode, and have a look. They are my inputs and they are my outputs. So if I click on these inputs, I can activate them. And see what is happening. But as you can see, nothing is happening. Why nothing is happening? It's very simple, because I am not in run mode. Oh, it's actually running. Oh no, it's not in the run mode. So I should push this button. Once I push this button, the simulator goes to the run mode, and now whatever I am doing, I should see what happens. So you can see that I press one of these lights, the 0, then output 2 is engaged. Again, if I turn that off and I just press the output, the second output, switch 2, output 1 again is engaged. But now if I turn both of them on, then both of them turns on. So as you can see, programming is not that difficult, but there are some stages. You need to definitely follow these stages. In summary, if you wanted to follow these stages, let me anyway stop this. If you wanted to write a program, first of all, you need to select the right hardware, and you need to make sure that the hardware you're using is exactly matches the hardware, the physical hardware that you have. That's the first thing. And the second thing that you need to do is actually setting your inputs and outputs. So we give them a name, and by giving them a name, we decide that which inputs and outputs we're going to use. Number 3, you need to start writing the program. And writing the program here is using ladder. As I said, there are some other languages, and you can follow all of these languages. What physical hardware do we have at Wintec? To be honest, we haven't yet purchased so machine. We have Twido. At present, we have Twido machines, but Twido machines obviously are not so machine. So we buying one to start with, and after that we're going to buy more of them. But at present, we don't have any of them. But anyway, as you can see, they're not very different. The language of them are all similar, and the configuration of these devices, yes, the configuration is different, but for the task that you are doing in PLC programming one, the simplest machine takes care of that. So you don't need to really worry about advanced items. Later on, once you do in PLC programming 2, then you will make use of the PLC that I show you, which is M340, a lot more advanced. But anyhow, for now, it should be all right. Anyway, after you finish with your program, you need to check if your program is working. Here we have a setting as well. I haven't touched that setting that much, but as you can see, there are some stuff that you can consider and you can make a change. And once you finish with your program, all you need to do is to just run your program. First of all, check your program, and after that, run that, and then you can go to display the program, and then the commissioning. And in commissioning, obviously, you can decide what you wanted to do with that. Okay, guys, is that making sense to you? What I wanted you to do Okay, got some chat. Excellent. Thanks for your feedbacks. Have to look over it. Absolutely. What actually I wanted you to do this week, I mean, I word that and I'm going to send you an email tomorrow. What I wanted you guys to actually go and get this program, install it in your computer and play with that. Because that's the only way that you can remember these stages. Otherwise, what I am telling you is just something to remember now and forget another hour. And maybe, anyway, we're recording this, so maybe you can sort of watch this recording at the time that you're doing it. If you forgot any of the stages, you can just catch up on the recording and learn how to finish the task. All good? Okay, I can't hear you actually. Maybe you wanted to open your mic, Chris.
No, that's all good. Thanks, Ali.
Appreciate that.
That's going all right.
Okay, excellent. That's good. Okay, so just about, I mean, I'm going to send you one email, and that email is going to be detailed. That's what exactly I wanted you to do during the week. It's going to be tomorrow, but just don't forget, the next meeting is going to be on Tuesday, because apparently most of you guys wanted Tuesday afternoon, so happy to change it to Tuesday afternoon. And after that, you're going to have the block course. Obviously, during the block course, you will receive detailed information and also information about this sort of video session. So, I mean, most likely it is going to be the same way, the same format. Anything to before finishing? Any question? Any comments? Request?
What are we going to be doing on the block course, Ali?
During the block course actually has different sections. You will work with relays, okay, and also you will work with input and output. I haven't yet told you about that, but that's actually going to be the next step. We have different types of inputs and output. We have derived inputs, thinking inputs, as well as outputs. They can be coming in separate ways. So the first block course is Introduction to PLC Program 1, as well as working with terminals and getting to know about source thinking inputs and outputs. The second one is going to be working on your project. So basically the project, I mean, you looked at the project, we have some projects for you guys to do. So for that, that project, basically you come into Wintec to finish your project. You finish your project before coming, but you just come over there to test your project, match it with the hardware, and do all this tweaking, all the tweaking required, with help of the tutor, obviously. Okay, guys, all good?
No, that's all good, Ali.
Excellent. And Darren, got your message. I would say most likely yes. Most likely yes. So yeah, anyway, Graham Rogerson is going to take the block course, and during the block course, you will receive the full information and also, I think, a little bit of planning as well. Okay, that's good. Hey guys, have a nice day, and I will see you next week, Tuesday.
Thanks, Ali.
You are
Good.
most welcome. Some of those guys doing projects? Some of them doing projects, I guess, yeah. No. Guys, some of you doing engineering project, right?
Yes,
But Brendan is doing that. So
and Darren as well.
oh, okay, and Darren as well. Do you have a word with them?
Darren is coming.
Yeah.
Oh no, Darren is doing a video.
Okay, Darren is doing the video. Okay, so all good.
Yeah.
All right, guys.
Jared,
Good night.
Jared, him.
Yeah.
Good night, Ali. Thanks heaps for that.
Right.
Bye,
Cheers.
Jared.